We want to prove this relationship using mathematical induction. So first I will do for n is equal to 2. For the left hand side we can see when n is equal to 2, that is 3 to the power 2, which is 9, and right hand side becomes 9 here. 3 to the power 2 minus 1 is just 3 minus 1 and over 2, so that's 3 minus 1 is 2, so it becomes 9. So left hand side is equal to right hand side for n is equal to 2, the first number. Then we can assume that when n is equal to k, left hand side is equal to right hand side. That's what we will assume to go forward. And when that is assumed, left hand side becomes 3 square plus 3 cube plus 3 to the power 4 plus up to 3 to the power k plus 3 to the power k plus 1, like that. So that's our left hand side. And but we have sorry, that's a bit of a mistake. Sorry, this is left hand side and this one will become is equal to right hand side. So I was directly doing the k plus 1 thing. So this is the left hand side, and this one is equal to 9 3 to the power k minus 1 minus 1 over 2. So this is what we are assuming. This is the left hand side when n is equal to k, and this is the right hand side when n is equal to k. So that's we assume. Then we move forward to see what happens when n is equal to k plus 1. So let's see what happens to the left hand side. Left hand side becomes 3 square plus 3 cube plus so on, so 3k plus 3 to the power k plus 1, like that. Now this one we assumed here. This one is actually this one, the right hand side when k n is equal to k, so that becomes 9 3 to the power k minus 1 there over 2, and then plus 3 to the power k, that's plus 1. Yeah, it's there. So this one can be written here 9, so 3 to the power k over 3 minus 1 there. That can be, if I get rid of the bracket, it becomes 9 here, and this one is 3 times 3 to the power k. So basically instead of writing 3 to the power k plus 1, I am writing 3 times 3 to the power k, so 2 here. Now this one we can get 3 here, so it becomes, on the next page I will do 3 times 3 to the power k minus 9 here, 2 here, plus 3 times 3 to the power k. So that is there. Now I will just do the addition, so it will be 3 times 3 to the power k minus 9 plus 3 times 2 here becomes 6 here, and 3 to the power k. So we have 3 times 3 to the power k plus 6 times 3 to the power k. So we can write 9 times 3 to the power k minus 9 over 2. So this is becoming, now if I take the 9 out, it is 3 to the power k minus 1 over 2. So this is my left hand side now. And if I look at the right hand side, when n is equal to k plus 1, it directly becomes 3 to the power n minus 1, that was. So when n is equal to k plus 1, it becomes 3 to the power k minus 1 over 2. So this is the left hand side, this is the right hand side, so they are equal. So when n is equal to k, we are assuming, we can prove that the relationship is we are assuming when n is equal to k the relationship is true, we are assuming that, and then we can show that then if that is true, the relationship will be true when n is equal to k plus 1. So we have proved the relationship using mathematical induction, this one.